Okay, Assalamualaikum and good day. So today we will cover chapter 3, the chemical engineering basic principles and calculation. So by the end of this topic, student will be able to describe and construct the concept of material balance, open and closed system, and student also should be able to explain and compare the steady state and unsteady state process. Let's go to the concept of material balance. What is material balance? And this material balance is actually based on the law of conservation of mass. Okay, the conservation of mass says that any matter cannot be created or destroyed in physical process. However, it can be only transferred or transformed. For example, in the combustion process, where the fuel react with the oxygen, it will produce or transfer into water vapor, carbon dioxide, and carbon residue. And now we move on to open and closed system. Before we move to open and closed system, there is general mass balance equations that relates to open and closed system. So in general mass balance equations, the formula is given by input plus generation minus output minus consumption equal to accumulations. What are the meaning of these five terms? Input mean that the matter that enter through the system boundary. The generation is that the material produced within the system. The output is the product that leaves through the system boundary. Consumptions is consumed by the system. The accumulations is whatever being built up within the system. Okay, the accumulations is equal to zero for process that is steady state. So in material balance, there are process classifications. There are batch processes, continuous processes, semi-batch processes, steady state, and unsteady states. Let's go to each of these one by one. The first one is batch process. In batch process, the feed is introduced at the beginning of the process and the content of vessel are removed later, meaning that throughout the process there is no incoming and outlet from of the mass from the system. There's no mass cross the system boundaries between the time the feed is charged and the time the product is removed. So this batch process is a closed system, meaning that there's no mass cross the boundaries. For the semi-batch process, this semi-batch process is neither batch nor continuous. For example, the balloon. Okay, the helium balloon, there's only due to the pressure, the gas escape to the atmosphere. Okay, and the second example, if a tank, there's only inlet of component A and component B is blended into tank by which there's nothing withdrawn. So this semi-batch process is having only inlet or outlet. So this process, semi-batch, is always an open system and unsteady state process. So for the continuous process is having one feed being introduced to the distillation column, or in this case, distillation column. And there are two outlets. In this case, we have vapor pressure, vapor from the top, and liquid at the bottom of the distillation column. So in this process, we have the mass flow in and flow out of the process. So this called as continuous, steady state, and unsteady state. Steady state process means that the value of the variable of the process, such as mass, temperature, pressure, do not change with time. However, for the unsteady state process, these value are changed with time throughout the process. Let's take a look at this example by which the water is poured into a glass. Is it steady state or unsteady state? It is unsteady state process. It is open system, and since it only has one inlet, there's no outlet, it falls under semi-batch process. Now, I hope you understand what is semi-batch, transient, and open and closed system. That's all for today. Thank you.